landing with a speed of 81.9 meters per second and traveling due south. The jet comes to rest in 949 meters. Assuming the jet slows with a constant acceleration, we have to find the magnitude and direction of its acceleration. So this jet is traveling due south, meaning from north to south. So say this is our north and this is south. So the jet is moving that way. So it says landing with a speed of 81.9 meters per second. So when it lands here, right, that's our initial velocity, that is v0, call it 81.9 meters per second, and then it comes to rest. So when it gets here, right, it's at rest. So when something is at rest, the velocity is 0. So our v final is 0 meters per second. And how far has this gone? 949 meters. So that is our displacement. So if we look at the kinematics equations, so now we want to find the acceleration. So here it's 0 because it comes to rest. So let's use v squared equals v0 squared plus 2a delta x equation. You have to look at the three equations and see which one makes more sense to use, and keep in mind that sometimes you have to use more than one equation. So here v squared is 0 squared, v0 is 81.9 meters per second squared, plus 2 times a times 949 meters. So if you do this, you get a equals negative 3.53 meters per second squared. And you see that this has a negative. Does that make sense? So we start with v0, which is 81.9 meters per second, and then it goes to 0, meaning it's slowing down. So the acceleration is actually a deceleration. If it's a positive value, we call it acceleration. If it's a negative value, we call it deceleration. So the negative value makes sense because the velocity is decreasing. So here our magnitude, meaning how big, of a is 3.53 meters per second squared, and the direction of the acceleration, so direction of deceleration is south, so direction of acceleration is north.